Hey, good morning. Welcome to
Math problem number 169.
What do you know what's special about the number 169?
It's 13 squared.
13 squared. Okay, so today we were talking about multi-way ratios. So we're going to look at a ratio that has more than 2 in it, so it's different than a fraction. So what did we pull out? 6?
6, 10, and 8. No, 8 I think.
8? Is that what it was?
Yeah.
Okay, 6, 10, and 8. I'm sorry, but I thought I was going to do 6, 10, and 12, but that's fine. So where's the 6?
6 is here.
Okay, so we got 6 stamp cubes.
There's,
Break them into pieces so they fit on. This is 10?
Yep.
Set. And 1, 2, 3, 4, 5.
and 8.
8. Okay, awesome. Now, the question is, can this be simplified? Can we break these up into smaller groups?
Well, I think they've got a common factor.
What is it?
Well, they've got 2 as their common factor.
Okay, so what do you think we might be able to simplify this 6 to 10 to 8 into?
Maybe 3 to 5 to 4.
3 to 5 to 4. Okay, maybe we can simplify this into 3 to 5 to 4, but we're not sure. Do you see any way to break these into one group of 3, 5, and 4?
Well, 3, 5, and 4, and 3, 5, and 4.
Okay, so here's 3, 5, and 4. Oh, I sure hope that white shows up on our camera. Now what we hope we're left with is a second group of 3, 5, and 4.
And here it is.
And here it is. Okay, so that seems to make sense, right?
Yeah.
Okay, so now let's look at another one. Give me some numbers. Give me 2 numbers, and I'll make up the third one.
Maybe 7, 8, and 6.
Okay, fine. 7, 8, and 6. Okay, can we break this up at all? So let's get 7. Can you get me another brown block, please? 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, and then 6. I suppose we already had 8 and 6 from last time, didn't we? Alright, here's 7, 8, and 6. Do you think there's any way we can break these up? Like the 8 and the 6, for example, have a common factor.
Yeah. The 8 and the 6 have, again, a 2.
A 2. Okay, so
That can factor down into 4 and 3.
okay, but that's just that part there, right?
Yeah.
But we have the whole thing all together now.
Yeah, but 7 is prime, so it can't be simplified.
Can't be simplified. So if we tried to factor a 2 out of this,
It wouldn't work.
it wouldn't work because we can't factor a 2 out of there without getting a fraction,
Yeah.
right? Now let's do one that's even maybe a little bit more tricky. Let's do, maybe the one they did in the book was interesting. 6 to 10 to 9.
Ew, cool.
All right, see all of these. Can you get me 3 dark greens? All right, so do we have 6 to 10 to 9 here?
Oh,
All right, all of these can be broken into pieces, so none of them are prime here. So can we make this 6 to 10 to 9 a smaller?
well, again, we have the common factor here, but 9 does not have a 2 in it.
Right, there's no way to break this one up easily into groups of 2.
Yeah, and these have a common factor, but this one does not have a 3.
Oh, that's interesting. So these, the 6 and the 9, we actually could break up into groups of 3, right?
Yeah.
But we can't break the 10 up into groups of 3. Darn it.
Yeah.
Okay. So what can we do to simplify this?
We can't.
Can't.
Again, we can't.
Can't. That's pretty neat, right? So
Yeah.
if they all have a common factor, then you can split them up.
Yeah. But
Like-
then,
Like if this was 12, what could we do here?
we could simplify out a 3, and that would be 2, 4, 3.
Okay, so let's make it a 12. Can you get me 2 more white blocks? If it's a 12,
We can.
look, I've got 6, 12, and 9,
And we can.
which I can happily break apart into groups of 2 and 4, 3. So See that?
Yeah.
You see another group of 2, 4, 3?
2, 4, and 3 here, and there's one more.
Okay. So if they all have a common factor, we can break them up nicely into groups. But if they don't all have a common factor, then we're just kind of stuck, right?
Yeah.
And that has a name in math, actually.
Cool.
Relatively prime,
Cool.
when they have no common factors. So not prime, but relatively prime. Prime means it has no factors other than 1 in itself.
Yeah.
Relatively prime means the numbers have no common factor.
Cool.
All right. Good job this morning, sweetie pie. Good job.